You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more conversations and articles, please visit thenewstack.io. Now on with the show.
ScyllaDB is the database for data-intensive apps that require high performance and low latency. It harnesses the ever-increasing computing power of modern infrastructures, eliminating barriers to scale as data grows. Game-changing companies use ScyllaDB for their toughest database challenges.
Hi, welcome to the New Stack Makers podcast. I'm your host, Heather Joslin, features editor of the New Stack. And today we're here to discuss how to make the decision to use database as a service, what advantages might be to having a managed database as part of your stack, and the challenges that might arise. We're going to do that through a case study involving the company GumGum, a global media company that analyzes digital media in a new way, scanning sites for relevant or risky content before ads are served. We're joined by Keith Sater, Director of Engineering at GumGum. Hi, Keith.
Hi. Greetings from LA.
Oh, terrific. And also, we're joined by Dor Laor, CEO and co-founder of ScyllaDB, a database his company produces an open source NoSQL database that powers data intensive applications. Dor's company worked with GumGum on its managed database project.
Hi,
welcome, Dor.
Greetings from Israel.
So we got a pretty international conversation happening here, and it's definitely a universal issue that a lot of companies are dealing with. Before we get started, we just want to thank ScyllaDB for sponsoring today's podcast episode. Keith, let's start with you. Can you tell us a little bit about what GumGum does? Because it's pretty interesting, and also the role of Verity, the artificial intelligence platform you use.
Absolutely, I'd be happy to. What GumGum is a contextual ad serving company. So how does that make us different? So I'm going to expand a little bit here because people have run into ads, and I'll use my case study that I talk to people about, where let's say Dor is going snowboarding in Switzerland and he needs new socks, right? So he goes to his favorite apparel website and goes, I want socks, buy some socks. He has now been marked as a socks intender by all the behavioral targeting. So from here on out, the next website will go, hey, Dor, would you like some more socks? No, I'm booking travel. Or, he goes to like his favorite snowboard place, like, would you like more socks? Like, no, I'm looking at new snowboards now. Or, say it's like he just wants to book dinner reservations. Like, would you like socks now? I just bought socks. I really did. I don't need you to follow me around anymore. What context does, it doesn't depend upon who the person is. It depends on what audience they're in. So GumGum's targeting for contextual targeting is basically like, okay, you're going to Switzerland. Let me give you ads relevant to Swiss travel or relevant to Switzerland. You're booking dinner. Oh, do you know there's a new restaurant opening? So what we don't do is we don't follow you around the internet. We go, oh, here's an audience. Let's target based upon the audience characteristics of that. So that's what makes GumGum different as an ad serving platform. So with the cookie apocalypse coming in, we're kind of insulated from that because we don't care what you did before. We care where you are right now. Now with that, how we do that is through a combination of good campaign selection, good creative selection, and then by what's called contextual targeting. And that's where Verity comes in. So basically for all of our publishers, we send a list of URLs to Verity. Verity goes in and basically categorizes those URLs as different IAB categories. So IAB has tons of taxonomies based upon autos, based upon clothing, based upon entertainment. And then that's how we do our targeting through Verity. So essentially we send a URL to Verity. Verity does its machine learning magic. It sends us some updates in some of our managed data sources. From there, we serve ads based upon that campaign targeting. And that's kind of what GumGum does. So, and the other part that's cool about Verity is it's not just our internal project. We will sell it to you. If you want to do contextual tracking, contextual categorization, we can help you with that as well. So that's a little bit about GumGum.
Okay. And obviously that generates a lot of data, and where are you storing the data? Where are you storing the data that came in?
That's a great question. The better question is, where don't we store data? It's kind of a, so we have a, like many large data sources, our data users, we have a polyglot system. So you can think of this as our configuration data is all relational data. We store that in MySQL, manage MySQL. All the Verity targeting data we store in Dynamo. But all of the actual sort of daily tracking stuff we store inside of ScyllaDB, which is a Cassandra protocol-based data source. So one of the core things about our advertising platform, while we don't track you, we also don't want to overserve you. So let's say Dor is looking at dinner reservations, we show him the restaurant. Well, he's already seen that ad. We don't need to show it to him again. So what our Scylla system does, we call it Tally, is sort of the backing data as the backing system, is that it counts and goes, well, Scylla, you saw that. Okay, you don't need to see that again. We need to select another ad of our inventory or potentially set a potential set of bids to show you again. And that's where Scylla comes into the picture for us. So Scylla is our rate limiter on ad serving. We store data from impressions in S3. I think that, and then we have various local caches inside our multiple VMs. I think we do memcache for like local creative storage. So that's kind of like a broad picture of our data storage systems.
Okay. Let's outline the problem that your company was trying to solve when it arrived at the question of the question of whether it needed database as a service. Can you tell me a little bit about that?
So this happened before my tenure at GumGum, but I'll try to recreate this as best as I could from my various Jira stories and backing emails and whatnot. We had a Cassandra-based system that some very smart people put in, but Cassandra relies upon you to have basically an engineering staff to support it. That's great, but like many types of systems, managing Cassandra databases is not really what our business makes money at. So thanks, we installed that. Now we're on to other projects. So we had this too many cooks in the kitchen problem with Cassandra. We were hosting it all ourselves, even though it was on AWS EC2 instances. It was just a pain to have somebody manage and dedicate time towards. So for us, the question is like, where do we spend our limited funds? Do we spend it on Cassandra maintenance, or do we hire someone to do it for us? And that's what really determined the switch away from a sort of self-installed, self-managed Cassandra to an other provider. And that's where Scylla came in, because Cassandra has sort of a few issues out of the box in terms of its architecture versus the scale we have. So Scylla solved a lot of those for us and could handle everything else for ourselves. Now, what we did is we brought our own hardware to the picture, which Scylla supported us on. So we said, we have this cluster of machines. What can you do with them? And they're like, that's fine. We'll take your machines from you, give us the EC2 IDs, and we'll do all the management for you. So essentially for us, it's like we make tables, we write queries, we ask for nodes to be provisioned that we provide. Other than that, they handle all the infrastructure for us. And the core thing for us is essentially they did a price point which was not that much more than what we were paying out of the box just for hardware alone. So in terms of support, in terms of database engine updates, in terms of advice on how to use our internal structures, Scylla has been a big win for us.
Okay, so it sounds like part of the issue was the labor intensive nature of having Cassandra, you're not in the running Cassandra business, right. You're in the
ad serving business.
Yeah, and cost is another issue, and so were there any other factors you considered when you're making this decision?
We had to have the right backing data store for it. So we considered multiple data stores. We considered like Dynamo, we considered Redis, we considered a few other items as well. The core thing that Cassandra protocol got us is we had that consistent count around the globe. So for instance, our ads serve globally. So if you see an ad in one place, we need to make sure if you fly across the country, you don't see it again in that different geolocation. So, while this data is ephemeral, it needs to be consistent around the globe, and that's what the Cassandra protocol bought for us. And that was what Scylla helped us with along the way. So, it keeps us from over-serving, because as an ad server, every time we handle a request, whether we actually place an ad or not, it costs us money. Over-serving is money out the door. That's the problem Cassandra, the Cassandra and Scylla stack solve for us.
So you're looking for something that could be an analog to that, or could be like that. You mentioned also something you brought up is an issue with data is geographic regions and the different regulations and different about data in different areas. And you meant I was struck by the phrase cookie apocalypse, which would make a great band name, I think. How big an issue is that for? I mean, was that also? I mean, sounds like that was a major factor as well. Just someone who could help you
with the cookie apocalypse, we're kind of
regulatory
insulated just by our business structure. We don't really target based on behavioral data, which is mostly cookie based. So from that side of view, we're fine. But just taking the volume of events that we get in and keeping consistent around the globe to make sure that counter in Japan is equivalent to the counter in the US, that was the core problem that we solved for those campaigns.
Okay.
So you can think about this. If I have an ad campaign or an ad line that's showing in multiple regions, I want to make sure they're not overserved in any region. And that was the problem that Scylla in particular helped us solve.
Okay. And Dor, this is where your company enters the story. Can you recall what the initial conversations were like with GumGum and the initial steps it took to make this transition?
So GumGum is our super talented team, and happy that they're solved the cookie apocalypse and ad serving challenges that we didn't have a clue in. We just help with data and with real-time data. And we help companies like GumGum to scale and scale across multiple regions. And while latency is extremely important, single-digit millisecond latency, and sometimes compatibility with existing databases can be Cassandra, can be also the DynamoDB protocol that we do support. And basically, Scylla is a much more efficient database implementation. That's why it's possible to transfer pretty much the same deployment at the same cost that you would pay for the hardware previously with other databases. Couldn't be Cassandra, but it can be today. We assist organizations to move from MongoDB or from relational databases if they cannot scale or more, to a much more efficient implementation closer to the hardware as we've got today. And the cost sometimes will be cheaper than the hardware itself or similar to the hardware, while the benefit beyond the ability to run fast database queries, the benefit is simplicity. We take all of the responsibility and the complexity of managing a distributed database and keeping it always on, no matter what happens, whether servers fall or data centers or zones get killed. We provide this always on guarantee, and we have both machinery and automation around this, and also a team of engineers and support people to make sure that if something happens, we'll continue to assist the customers. And this is how we assist GumGum, and this is how we assist other companies as well.
So how do you maintain that 20, always on? What are some of the factors that allow it to do that?
Our database in its root implementation, and we did follow previously in previous implementation of other distributed databases, such as Cassandra and such as DynamoDB, and they followed Google's big tables, et cetera, et cetera. So we have a big legacy of infrastructure that's supposed to be resilient. So, for example, every implementation of ours has configurable consistency. So you can have multiple replicas, and if you're deployed in a region like US East, for example. So within a US East region, it's not just one physical location. You can split it into a zone-aware deployment, where if we have, for example, 3 replicas, every set of replicas will be implemented in its own zone, and a complete zone can just get completely wiped off, while the data center will still have a Chrome and will still be able to support queries. Now, this is a single data center, and many times organizations have multiple data centers. Sometimes it's for disaster recovery. Sometimes it's also to shorten the latency and be closer to the client. And that's also the case with GumGum, who have data centers in Japan too. And all of these data centers are completely in sync. And that's why whatever happens, then you're absolutely protected from any type of failure. And that's why we don't need humans to be able to meet this guarantee. And of course, it's always good to have humans, because sometimes unplanned disasters do happen beyond the standard.
Keith, I understand you have an interesting story about the install.
Yeah, this goes back a ways. So like many other customers, I'm sure, who come to them, we came with a Cassandra instance. It wasn't quite off the shelf complete. So Scylla was very handy in making our own custom Snowflake install of that as we went. So you can think about this where it's, we had some very talented people here. It's like, oh, we need to make Cassandra do X. So we made Cassandra do X. And for the life of me, I can't remember what it was. I think it had to do with a consistency mechanism. But then we went to Scylla and go, well, this is working for it, but it's not doing this consistent thing that we need it to do. And they're like, hang on, let us fix it for you. So we not only got an upgrade of our cluster, we got our own special version of that. Now, I don't recommend that for folks, but to their credit, throughout my entire tenure here, every upgrade has moved us closer to what I'd call default production. And every upgrade for them has gone flawlessly for us. I have experienced 0 outages with them managing our machines. Mm-hmm. That was a load of engineering and engineering talent we didn't have to spend for.
Mm-hmm. What were there challenges during this transition to ScyllaDB? I mean, this, I guess, question for both of you. If you have sort of lessons learned from the
sure
from the experience.
Well, and this is a humorous aside. No, we just replaced the box and the diagram with Scylla instead of Cassandra. It all went magically. That's in my original presentation for the Scylla Summit a year ago or so. Yeah, of course there were. So part of not being a data engine expert or expertise is we had some really inefficient Scylla systems or Cassandra systems. And during this install, that was all brought to bear where it's like, we had really hot shards from time to time because Cassandra sort of obfuscated that. And by its architecture, it says, well, the OS is going to distribute it for you and we'll do our best. If there's enough threads and memory to allocate to this, we can make your inefficient query seem efficient. Scylla doesn't do that with their thread per shard, thread per core architecture, if I'm pronouncing that correctly, remembering that correctly. So that really said, you have these hot nodes you need to fix because these queries and these key spaces are inefficient. So that was a lesson we learned with them. And as we continue to partner with them, for instance, last year, we had a system that was using what's called an allow filtering clause in Cassandra, which is kind of super inefficient past a certain scale in tables. And they helped us redesign that entire table space. So those are like some of the things that we've benefited from partnering with Scylla and their engineering expertise.
Dor, do you have any thoughts about?
Sure, but by the way, Keith, how long we go back to the initial migration? It was prior to your time, so it's right. Multiple years. Yeah. I guess easily 3 or 4 years. I guess.
Yeah, I was looking today, and it's like 2019. I think was like our first Jira stories, and they're like late 2019.
Okay, cool. Now, just like that, things with if someone migrates from Scylla or Dynamo or other system to Scylla, things supposed to be as smooth as possible. But sometimes because when people migrate to Scylla, they try to optimize the system or adjust it to some type of a better implementation or just to save hardware, for example. Then once you do that and you move from like you chop 50% of your deployment, then it's more challenging for the database and sometimes problems pop where usually before, because there was so much hardware thrown at the problem, they were kind of below the threshold of being a problem. And so when that happens, then our engineering team and our support team, we love to jump and to try to solve the problem. I can, with the GumGum case, there was really an interesting technical aspect that indeed caused us to have a private Scylla version, as Keith indicated. The main challenge was there was a time where the client side on the database side used to throw many parallel concurrent requests, like in the hundreds of thousands per second, and even more, going even to millions. Mm-hmm. And the database capacity, we didn't want to, from the very beginning, to kind of have a too large deployment. We wanted the deployment to be as small as possible. And sometimes when clients do that with a few connections, then it's possible to try to slow them down, because every connection, the database will react slowly, and by nature, the clients will get slowed down. But in the GumGum case, all of these clients were new processes. So hundreds of thousands of processes all trying to connect to the database. It's really a connection storm that arrived to Scylla, and it was very challenging for us. And initially, we created a private version to solve it, and we have solved it. But we have kind of a design scheme of open source first, and we need to solve things correctly. And every new algorithm needs to have a thumb up by all of the maintainers. So it took, like, we wanted to first make sure that GumGum can run correctly without any issue. That's what we've done with the private version. And over time, we had to massage the algorithm, make sure that all of the code committers upstream are thumbing it up. And eventually, we designed a really nice submission control mechanism that measures the amount of parallel requests that the database, the distributed database, which it's more challenging this way, has in parallel, and to slow all of these requests that maybe arrive for the first time from a new process. So it was challenging, but eventually they got to the right version.
Keith, what would have been the results in terms of the business and for the teams, the teams at GumGum for having changed it to ScyllaDB?
Oh, I can tell you for sure. So we have pretty much reduced our entire operations effort with Scylla to almost nothing. Like, what we really do with Scylla at this point, we're coming into our busy point of the year. Ads really get picked up in Q4. So really what we do is we reach out to Scylla and go, hey, we need N more nodes in these regions. Can you make that happen for us? They go, yep, give us the things. We pay the money, and it happens. So for us, in terms of scaling for our Q4 expected volume, it's been pretty transparent. First year I was here, there were some hiccups, and we have to do some magic to make it work. But last year, we scaled up and nothing happened. As we sort of like increased our volume by probably 75% plus 50% over our standard. So the toughest thing to do in this industry is make things look easy, and Scylla helped us make ad serving look easy. And it's not, because we get bursty traffic. We get people like Yahoo we partner with who are like, oh, we're going to hammer you with 3 times the amount of QPS that you expect normally. Okay. And Scylla makes that transition for us fairly transparent. And the great monitoring we get from them as well makes it easy for me, even as director, to go, how are we doing here? Okay, our cluster's running at 63%. Fantastic. Good to know. And I don't think about it at night. Like, that's really the thing that Scylla has brought to us, is we can really focus on our business problems and not the infrastructure issues.
Yeah. And that's no small thing, it sounds like, to not have to be lying awake at night worrying about.
I don't have to page engineers and go, oh my goodness, tally is down. Can you figure out why?
And that's, I would think that would have, if someone is thinking about managed database as a service, I mean, I would think that would be a factor, just reducing pager fatigue, or just reducing, wear and tear on the operations team or the database administrators.
Yeah. Also, Keith touched a really good point about observability. Some managed databases do not provide really good observability, not just in the idle amount of percentile, but also ability to trace what the database is doing, and whether the client side that doesn't have the transparency to figure out what the database does, whether the client issues the right queries, because queries are a complicated matter. So having the ability to provide the observability to the customer, although the customer doesn't run the database on his own, is really important for the customer to make the best efficient use of the database.
Yeah, and it gave us a good time to really reconsider our data storage system in terms of like the layouts of it. So from that observability, we got to basically re-engineer a key table space inside of our Scylla cluster earlier this last year.
That's great. What do you know, Keith? What do you know now about using a database as a service that you wish you'd known at the start of the transition, and that you think maybe other organizations might want to know before they start this journey, a journey like
The
this?
biggest thing I think about when reflecting on this, and Dor has a bit more background than I do, so I'm coming all of this like third hand and from institutional memory from my boss and other folks who were around at that point. My thought is cleave as close to sort of the vanilla execution as you can before you transition over to a managed solution, because you're not their only customer, and what you're doing might not make sense for what they're doing. That is the biggest thing I can think of. So if you can make it like a drop-in replacement, especially Scylla Cassandra style, great, fantastic. That's probably not going to happen for them because that's just not the way businesses work. But anything you can do to ease that transition, I think about pretty hard, where it's like, oh, we're doing this one weird thing. Stop doing that weird thing.
Okay, stop doing the weird thing. That's a good just advice in general, I think.
Well, or
the weird thing.
Make the decision of either we do this or we don't do this. I think a lot of organizations struggle with, oh, well, but we've been doing this, and it's this sunk cost fallacy where it's like, well, we've been doing this, we can still handle it. Just trust me, let the experts handle this.
Dor, what might be the best use cases for a database as a service solution, like your companies or just in general?
Basically, in general, I think that it's a good practice to use infrastructure as a service, not just in data, not just with Scylla case, also with databases and other infrastructure, because engineering talent is hard to get, and you need to focus in your business. So we also use SaaS whenever you can of other providers. And in general, the problem that Scylla solves is real-time data at scale. So the more scale you have, then the more probably likelihood that you're going to need something like Scylla, because you can't, either the cost is too much, is prohibitive. Some providers are extremely expensive, or just not efficient, and that's rolled up to cost. Also complexity, that's another thing, or platform blocking. Some databases are only there on a specific cloud vendor, and there'll be a point where you need to migrate to another cloud, and you do not want to be locked, and we're a pure software vendor, so we can run on every cloud. So that's important when you implement all of these things. And if you do not use a service and you manage it on your own, it's absolutely a fine approach. But make sure that if you have enough scale to support it, because if you have not enough scale, then probably your engineers are better off doing something else. And if you still do that, make sure that you test all of the backup and recovery and high availability and disaster recovery, and not just implement them once and forget, because when there'll be an issue, then you'll be in a very big pain if that happens. You do not want to test your backup when your source is kind of died. You need to test it on a regular basis, and this is what the vendor does for its living.
Okay, great. Well, I guess that's it for now. We thank our guests, Keith Sater from GumGum and Dor Laor from ScyllaDB for joining us. Thank you, gentlemen.
Thanks, it was a pleasure.
Thanks, Keith. Thanks, Heather.
Yes, and we thank ScyllaDB for sponsoring today's episode of the New Stack Makers. I'm Heather Joslin of TNS, and we'll see you next time.
Thank you.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.